Hello students, welcome to my channel Positron. Dear students, today's topic is electric potential due to dipole. In my last video, I have discussed about electric potential due to a point charge that we have found out. Today's topic is electric potential due to dipole. As you know, electric potential is a scalar quantity, but you cannot say about the magnetic potential. Later on, you will also study magnetic potential. There is two kind of potentials: magnetic scalar potential and magnetic vector potential. Right? I'm not going to discuss at all. Today's topic is electric potential due to dipole. Dear students, you know, electric potential is a scalar quantity, right? So you have to, if a charge is q, a point is a smaller distance away, then potential at this very point works out to be 1 upon 4 pi epsilon naught q upon r. In the last video, the very first video based on electric potential, I have told you all at that moment that electric potential is a scalar quantity, and also if you know the nature of a particular quantity, then the things becomes very simple for you. You should know electric potential has a nature of energy. It is a nature of work. You define electric potential at a point is defined as a work done in bringing unit positive test charge from infinity to that point. So it is a work done in bringing unit positive test charge. It means the nature of electric potential is a work. In similar way, in the very first chapter, that was electrostatics, we are studying a part of electrostatics. In my first video based on electrostatics, charge and its properties, I have told you that electric field intensity is defined as a force experienced by unit positive test charge. It means electric field intensity has a nature of force. You write the unit of E is as a force experienced by per unit charge, that is Newton per Coulomb, right? In similar way, electric potential, how you define? You say the work done in bringing a unit positive test charge, that is Joule per Coulomb. And this Joule per Coulomb is also called volt, right? So what I want to tell you, that if you know the nature of a particular quantity, then things become very easy, very crystal clear, and it creates enthusiasm to know about that very thing. Now, dear students, we have to find out the electric potential due to dipole. What the dipole is? Let's talk about some molecule. Some non-polar molecule. The molecule is divided into two types. One is a polar and non-polar, and there is a non-polar. Non-polar is what? Like H2, O2, N2. Despite my topic is electric potential due to dipole, but you should have a basic knowledge of dipole. Dear students, in all this, they are bound by covalent bond. You know the three kind of bonds, right? Electrovalent bond, covalent bond, and subcovalent bond, and many bonds also are van der Waals bond, hydrogen bond. We'll discuss later. Now, dear students, this is H2O2 N2. Like O2, it is a homogeneous, means the same kind of atom are both sides. So it has a 286. So they share 2 electrons each, and so there is a 2 covalent bond. The shared electron, it is a homogeneous atom, shared electron lies just at the mid, right? It lies just at the mid. That is why there is no polarity on both the oxygen. But in the case of H2O, H2O is like this, right? It has a configuration. This has a configuration 286, means 2, 2, 2, right? And this has 1 electron. It needs 1 electron to complete its 2 electron in its first orbit, whereas in order to make it stable, it needs 8 electrons, you know, at a very basic. So it needs 2 electrons. So 1 electron shares with this and 1 electron it shares with this. It is a heterogeneous molecule. The two atoms are different. Now, you know, hydrogen is a more electropositive and oxygen is a more electronegative. What happens, dear student? Now the shared electron, it does not stay just at the mid of hydrogen and oxygen, but it moves towards the more electronegative. Oxygen is a more electronegative. It is a displaced a bit towards oxygen, so it becomes del minus and it becomes del plus. Now the two atoms of H2O, the hydrogen and oxygen, hydrogen has become a partially positive and oxygen had obtained a partially negative without applying in the absence of any electric field. Nothing, no any electric field you have applied. Hydrogen becomes positive and oxygen becomes negative. Now, dear student, this is a permanent polarity. Nothing you have done. It is automatically, it happens that the shared electron between the hydrogen and oxygen is displaced towards more electronegative. Oxygen is a more electronegative, so it is displaced towards it. And because electron is a negative, so the direction in which it is displaced or it is closer to oxygen than hydrogen. That is why oxygen will attain a bit negative charge, whereas hydrogen will attain a bit positive polarity. And now it forms a dipole. Dipole is a what? Dipole, where I have solved in the very first chapter, that was the electric field due to electric dipole. At that moment I have told you that dipole is a what? Dipole is it is a system which is consisting two charges of equal in magnitude, opposite in nature, right? This one is a positive, this one is a minus, and both are same in magnitude and separated by a little distance 2L. And then you say the dipole moment P is equal to Q into 2L. One charge multiplied by the distance between the two charges. This is called to be the electric dipole moment. Dear students, if you want to find out the dimension, you know, charge in some books somewhere we used to take charge as a fundamental quantity, but charge is not a fundamental quantity. You know, rate of flow of charge is called current, so Q is equal to I into T. So it is the dimension of Q is 80, 2L or L, no matter, it is a meter, it's a distance. So the dimension of 2L is a L, so it becomes the electric dipole moment is a ATL, and its a unit becomes, dear student, unit will be what? Q is a coulomb into meter, right? Actually, I was checking that whether I was not confident whether whole board is captured by camera or not. Now, I'm very sure you can watch. Now, dear students, this is the dimension of electric dipole moment, and this is the unit of dipole moment. The very important what we have to know. I have said that electric dipole is a what? Electric dipole is it is a system consisting two charges equal in magnitude, opposite in nature, separated by a little distance between them. Now look here, this is a plus Q, this is a minus Q, this is the distance between the two charges. Dear student, what should be the range of this distance? This distance is always in angstrom, right? It is not that you made so big, it is just a representation. This distance is in the angstrom, and it is not a point of our, it is not a choice of our point, right? Nothing we can do here. It is always in angstrom. These are the basics, you know. Now let's move. Electric potential due to dipole. This is a dipole we have considered, right? This is a plus Q, this is minus Q, and this is the center of dipole, right? Let it is A, this is B, and a point P here, which has the position vector R1, right? It has a position vector R with respect to center, or with, and this has the position vector r1 and this has the position vector r2, like this, right? The center has a position vector r, with respect to center. P has the position vector r. With respect to A, it has the position vector r1. With respect to B, it has the position vector r2. You know, electric potential is a scalar quantity. So the potential by the diagram you cannot show, because it is a scalar quantity. Scalar quantity cannot be drawn here, right? So what we used to do, we used to take, in order to find out the potential at a point due to many charges, what we used to do, we used to take algebraic sum with sign. So potential at point P, V is equal to, due to this one, that is a 1 upon 4 pi epsilon naught Q upon R1, right? And due to this, due to positive charge, potential is a positive, and due to negative charge, potential is a negative. And due to this one, here the potential will be minus 1 upon 4 pi epsilon naught Q upon R2. Now, dear student, it becomes Q upon 4 pi epsilon naught 1 upon R1 minus 1 upon R2. You find this. Let this is the way equation 1. Now, you have to solve this 1 upon R1 and 1 upon R2. Dear student, let this angle is a theta. Suppose that this angle is a theta, right? Now, if it is 2L, then this is L and this is L. Now, you know this angle is an acute angle. There is a cosine law, you know. From this equation, from this triangle PCB, what you can write? R2 square equal to R1 square plus L square minus 2RL cos theta, right? If it is an acute triangle, then you can write, if this angle is acute, then the cosine law becomes, the side in front of this angle is a R2, so R2 square equal to, this is R square plus L square minus 2RL cos theta. Now look here, in this triangle, right, this angle is a obtuse and it is a 180 minus theta. This is 180 minus theta. What becomes this law? This is in front of this angle, opposite to this angle, the side is this. So R1 square, that is equal to this R square plus L square. Look here, it was a R2 square equal to R square. This should be R square, sorry to say. Now R1 square equals to R square plus L square. Dear student, if you write minus 2RL cos 180 minus theta, cos 180 minus theta, this is in second quadrant you will get, and in second quadrant, it is sine and cosec is a positive and others are negative. So other trigonometric functions are negative. It means cos theta is negative, so it becomes this much, right? Now, dear students, what we have to do, we have to find out 1 upon R1 and 1 upon R2. So, I am trying to solve this equation in this way. Look here, R2 square, that is equal to R square take out. So, it will become 1 plus L square upon R square minus 2RL upon R square. 1R will be cancelled. This is 2L upon R cos theta. Now, in similar way, R1 square equals to R square 1 plus L square upon R square plus 2L upon R cos theta. Dear students, look here, L, it is either be the 2L or be L, no matters. It is a distance of range of angstrom, means 10 power minus 10 meter. And R is a point of your choice. Even it's a very tough for you to measure the distances in millimeters. So your point of your choice will always be greater than 1 millimeter, right? So R is much greater than the L, or you can say that L is less than R, and L upon R is again less than 1, and a quantity less than the 1, if for the higher powers, if power becomes higher, it becomes much and much smaller. So L square upon R square is a very less, very negligible quantity. So neglecting these two, and we'll get, look here, I'm writing here. So R2 square equals to R square 1 minus 2L upon R cos theta. Or you can write 1 upon R2 square equal to 1 upon R square, and this will actually be in denominator, but we are bringing it into numerator like this, 12 upon R cos theta inverse. Now it is a 1 upon R, this is R2 square, 1 upon R2 equal to 1 upon R 1 minus 2L upon R cos theta to the power minus 1 by 2, taken the square root throughout the equation. Now dear students, you know first order binomial expansion, 1 plus x to the power n equal to 1 plus nx. Condition is that n and x should be less than 1. Now look here, this is a small r is a distance of point, right? And that is of your choice, and your choice would be in millimeter or centimeter, right? L is a distance of dipole, and that is in the angstrom range. So L upon R is again and again very small, and here n is less than 1. So you might apply this concept here, and you will get, look here dear student, 1 upon R2 equal to 1 upon R. This would be multiplied by minus 1 by 2, 2 will be cancelled, so it will be 1 plus L upon R cos theta. Dear student, for 1 by R2 we have got 1 upon R, 1 plus L upon R cos theta, and 1 upon R1 similarly becomes 1 by R, 1 plus 1 minus L upon R cos theta. Dear students, let's replace these values in equation in equation 1. Just I'm removing this, okay? I'm erasing this. Look here. I'm very sure you people are following. There's nothing very special in this. V is equal to Q upon 4 pi epsilon naught. Now, 1 upon R1 is equal to 1 by R. That is 1 minus L upon R cos theta minus 1 by R2 is a 1 by R, 1 plus L upon R cos theta. Now dear students, look here, 1 upon 4 pi epsilon naught, Q by R taking out, V is equal to, so it is 1 minus L upon R cos theta minus 1 minus L upon R cos theta. 1 minus 1 will be cancelled, so here it is a minus 2L upon R cos theta. Or you might write V is equal to minus taking out Q into 2L cos theta upon R, or V is equal to minus 1 upon 4 pi epsilon naught. Now Q into 2L is what? Q into 2L is the electric dipole moment that is expressed by P. It is a P cos theta upon R. V is equal to minus 1 upon 4 pi epsilon naught. This R and R will be multiplied, so it will be R square, sorry. So V is equal to minus 1 upon 4 pi epsilon naught P cos theta Q into 2L. I have expressed, turned it by P, electric dipole moment. P is equal to Q into 2L. Here 1 will be cancelled. You will get 1 minus L upon R cos theta minus 1 minus L upon R cos theta. 1 minus 1 will cancel. So it is a minus 2L upon R cos theta. So minus I have taken out. This is 1 upon 4 pi epsilon naught Q into 2L cos theta over R square. This Q into 2L is an electric dipole moment P. So V is equal to that much. Now dear students, look here. If you take mod, actually here positive or negative no matters. It depends on that what was the position vector of Q you supposed and what was the position vector of minus Q you have supposed. That is, if you have supposed the position vector of minus Q R2 and Q R1, then answer would have been in positive. It's immaterial. I am taking mod, so minus will cancel. It is a 1 upon 4 pi epsilon naught P cos theta upon R square. This is the value of potential. Dear students, I am erasing this part. Now let's discuss. We have got, it was our dipole. This is plus Q, this is minus Q. It was the center of dipole. It is 2L, right? So it is L, it is L. And here was a point P making an angle theta with the axis of dipole. And this was position vector R, and I think it was R1, and this was R2, right? You have got V, mod of V is equal to 1 upon 4 pi epsilon naught P cos theta upon R square. Now, dear students, this is the value of potential due to dipole at point P. This is the value of potential at point P due to electric dipole we have observed. Look here. If point P would have been here, means on the axis of dipole, the point is axial. If point P is existing at the axis of dipole, then theta is equal to 0. Theta is equal to 0 because this line will become like this. And so if theta equals to 0, cos 0 is equal to 1. So V becomes 1 upon 4 pi epsilon naught Q upon R square. In this way, the potential becomes when the point is lying on the axis of the dipole, right? Then our point is axial, then V is equal to 1 upon 4 pi epsilon naught P, dipole moment, P upon R square. Now, dear students, what happens if the point is lying here, right? Means theta is equal to pi by 2. In equatorial position, point P is existing in equatorial position, means at the perpendicular bisector of dipole. Then what happens? Theta is equal to pi by 2. In this case, cos pi by 2 vanishes. That is, so V is equal to 0. Potential would be 0. In this case, potential will be 0. And similarly, you can just watch from here also that it is a dipole. This is plus Q minus Q, right? This is L, this is L, this is R. Now it will be R square plus L square. This will also be R square plus L square, right? Now the charges are same, distance is same, and potential due to point charge at a point V is equal to 1 upon 4 pi epsilon naught Q upon R. Now dear student, due to this charge at this point P, potential will be 1 upon 4 pi epsilon naught Q upon this much, and due to this minus Q charge, potential at point P will be V is equal to minus 1 upon 4 pi epsilon naught Q upon this much, and so both the values are same but are opposite in nature, and that is why one is a positive and the is a negative, so they will cancel it. And there is a next topic is a electric potential energy. That is called to be the EPE. Electric potential energy. How will you define and how will you find out the electric potential energy of the system? And for the JEE aspirants, it's going to be very important topic, because every year the questions are being asked from this very topic. I'm beginning from very basics. Let the two charges are Q1 and Q2. Dear student, let the two charges are Q1 and Q2 and they are at a distance small r apart, right? The two charges are Q1 and Q2 and they are small r distance apart. Now, dear student, we have to find out the electric potential energy. First, we have to define that what electric potential energy is what. How will you define the electric potential energy? You know, electric potential, how will you define? You say the potential at a point is defined as the work done in bringing unit positive test charge from infinity to that point. Potential at a point is a work done in bringing unit positive test charge from infinity to that point. In similar way, EP, how will define the EP electric potential energy? It is the work done in bringing these charges from infinity and assembling them, or work done in assembling, in bringing these charges from infinity and then to assemble them, right? Means these charges are actually at infinite and then they are brought and assembled here. Now, this work done we have to find out in bringing them from infinity and then assembling them. Nothing is very special. You can say that, dear student, either you find potential due to this charge at this point. What I am doing, I am trying to find out the potential due to this charge at this point, and we know V is equal to W upon Q. So, if at a point potential is a V and charge Q you have to brought from infinity to that point, then work done is equal to W is equal to Q into V. The same process I am applying. Look here, what I am saying, that I am trying to find out the potential at this point due to Q1, and then we will say that Q2 charge is kept in the field of Q1, or you have an option that you can find out the potential due to Q2 at this point, and you say that Q1 charge is brought from infinity in the field of Q2. So I am doing that. Let potential at B due to Q1. What will be potential at point B due to Q1? This is going to be V is equal to 1 upon 4 pi epsilon naught Q1 upon R. Dear student, first we find the potential at point B due to charge Q1, and now what we are going to do that the charge Q2 is brought from infinity in the field of Q1, and you know work done V is equal to W upon Q. So W will be this electric potential energy of Q2, that is actually electric potential energy is not of Q2. It is electric potential energy of combination of Q1 and Q2. So this sentence is dropped. EPE of system. Better is to write like this. Now this is V is equal to W upon Q, or W is equal to V into Q, V into Q2. Now V is what? Look here, 1 upon 4 pi epsilon naught Q upon R. This is Q1 upon R and Q2 is brought here. So this is W, R, U is equal to that much. This is the electric potential energy of system of two charges, right? The two charges Q1, Q2 which are separated by small r distance, and then the electric potential energy U is equal to 1 upon 4 pi epsilon naught Q1, Q2 upon r. Dear student, in this formula, the sign has its own significance. If one charge is a Q1 and there is a minus Q2, then EP in this case has been, this is 1 upon 4 pi epsilon naught Q1 into minus Q2 by R minus 1 upon 4 pi epsilon naught Q1 Q2 by R. Dear student, this is the way to find out the electric potential energy of system of two charges. Case is, if there are the three charges, let three charges are, this is Q1, Q2, Q3, right? There's three charges are Q1, Q2, Q3. You have to find out the EP of this system. What the definition is says that work done in bringing these charges from infinity to point A, B, C, or work done in assembling these charges to A, B, C, bringing them from infinity, and that work done is stored as a EP, right? It is a work done in bringing the charges Q1, Q2, Q3 from infinity to point A, B, C. We have to find out this work done. And this work done will provide us the EP of the system. The better is to bring them one by one. We are bringing first Q1, right? If you are bringing Q1, then at that moment Q2 and Q3 was absent. What I'm saying that I'm bringing Q1, Q2 and Q3 charges one by one. So first I am bringing Q1. At that moment Q2 and Q3 were absent, and so if there is no any other charge and you are bringing Q1 at point A, then potential is 0, and so W is equal to V1. You are bringing Q, V1 is 0, so W1 is also 0, right? First we brought Q1 to point A. At that moment Q2 and Q3 were absent, and that is why V1 is 0, and that is why W1 is 0, right? Potential at a point will be due to any other charge, not because of itself. If we might be charge Q1 is at point A, then at point A, if you want to find out the potential at point A, then it will not be because of Q1, but it will be because of any other charges. And when you brought Q1, Q2 and Q3 were absent, that is why at point A the potential was 0, and that's why the work done would be 0. Now I'm bringing Q2 charge. Now let's brought Q2 charge. If you are bringing Q2, then Q1 already has come. So the potential at point P for Q2, when you are bringing Q2, Q1 already has came, right? Now the potential at point B due to Q1 will be, that is V2 is equal to 1 upon 4 pi epsilon naught. Let it is R1, this is R2, this is R3. You can say. So potential at point B due to Q1, that is 1 upon 4 pi epsilon naught Q2 upon R1, like this, right? Now you are bringing Q2 charge in this potential. So work done W is equal to V2 into Q2, and V2 is this much. If you write, then it becomes 1 upon 4 pi epsilon naught. Oh, sorry. For Q2, V2 will be because of this charge, sorry. At potential at point B due to this charge, that is Q1 upon R1. Sorry guys. So W2 is equal to V. Now you are bringing Q2. So potential due to this, potential due to Q1 exists here, in which charge Q2 is brought, and that is why W is equal to V2 into Q2, and V2 because of this potential here is 1 upon 4 pi epsilon naught Q1 upon R1. And now charge Q2 is brought, so it becomes W2 is that much. This is equation 1 led to. Dear student, when you are bringing Q3, Q1 and Q2 already had come. Now, potential at point C, that is V is equal, that is I am writing by V3. So, potential at point C, due to Q1 charge here the potential will be 1 upon 4 pi epsilon naught Q1 upon R3, whereas due to Q2 potential at point C, that is this is a positive charge, potential due to positive charge will be positive, so it is a plus 1 upon 4 pi epsilon naught. Now Q2 upon R2, this much will be the potential. Now in this potential field, a Q3 charge is brought, so work done W3 is equal to V3 is the potential at this point and charge brought is Q3. So replace this value of V3, you will get 1 upon 4 pi epsilon naught Q1 Q3 upon R3 plus 1 upon 4 pi epsilon naught Q2 Q3 upon R2. So dear student, total EPE of the system becomes total EPE of the system U is equal to work done in bringing charge Q1, that is W1, plus work done in bringing charge Q2, that is W2, plus work done in bringing charge Q3, that is W3. That is, we are adding W1, W2 and W3, and ultimately we will get W1 is 0, W2 is that much 1 upon 4 pi epsilon naught Q1, Q2 upon R2 this W2, this distance was R1, potential here it was R1, sorry. So it is 1 upon 4 pi epsilon naught Q1 Q2 upon R1 plus 1 upon 4 pi epsilon naught. This is Q2 Q3 upon R2 this is Q1 Q3 upon R3. Dear student, whole board was not appearing in the camera, that's why I have displaced the camera. Now I am very sure that you can watch whole system. Here what is that? First we find work done in bringing this charge. We are bringing one by one the charges. Now after that we are bringing this charge and then we are bringing this charge. We have find out the work done in bringing these charges, and ultimately I get this is the EPE of the system. In similar way, dear student, no problem how much charges are given, is immaterial. If there are the charges Q1, Q2, Q3, Q4, then you have, if you have to find out the EPE of the system, then what you have to do? First bring Q1, in that case work done will be 0. Then bring Q2. When you are bringing Q2, Q1 already has come, so find out the potential at this point due to Q1 and then bring this. So W2 is equal to potential due to this, that is V1, and then charge brought is Q2. And after that, if you want to find out, you have to find out work done in bringing charge Q3. How? First find the potential due to this charge at this point and then find the potential at this waypoint due to this way charge, and so net potential, just take the algebraic sum because potential is a scalar quantity, and ultimately W is equal to V3 Q3, and then least but not last you have to find out the work done in bringing charge Q4. When you are bringing Q4, Q1, Q2, Q3 already exists, so at this waypoint find out the potential due to Q1, due to Q2 and due to Q3, take the algebraic sum of that, and then W4 is equal to no doubt V4 into Q4. In this way, you have find out the work done W4, and ultimately the total EPE of the system, that is W is equal, U is equal W1 plus W2 plus W3 plus W4. You will add and you will get the result. In this way, dear student, but at the level of JE or NEET, especially I'm talking about the JE, there is a combinations work, right? There is a sort of type of questions being asked, what kind of questions are being asked and how to solve them easily, right? We will, in next video must will be the part based on the to solving the questions related to the electric potential, because potential is a scalar quantity, so questions are not going to be typical at all, right? So I hope you people are enjoying my video. If you think that my videos are beneficial to you, then it's a humble request to you all that please share, subscribe, and must put bell icon so that you might be notified about my next video. Thank you. Meet you in next video.